Okay, we're going to be looking at these three problems in this video. So let's look at the first one. Let's make some room. All right, so the first thing I see is this right here. And quarterly means n is going to be equal to 4. And the formula I need to use is this. So compounded n times a year. That tells me that the R is going to be 4.9 divided by 100. Initial deposit is that, so that's our P. And my time is going to be 12. Okay, so we come down here, and I'm just going to fill in the blanks, or the letters that I've found. And up here we're going to have 12. Oh, N is 4. 4 times 12. N times T. Well, 4 times 12 is 48, so I might just save myself some work. Now I'm going to do this all in one go. I am not going to work out the parentheses first, because when students do that, they tend to round their answer. If you're going to work out the parentheses first, you better, and it's a long decimal string, you're going to have to take the whole one. So I'm just doing it in one go. And this is the safest. You never round until the end, the very end. So let me clear this. I'm going to have 5,000 parentheses 1 plus 0.049 divided by 4 to the power of 48. Okay. And then at the end, I'm going to round, and it's to dollars and cents. So I'm going to have 8969. And rounding it to 2 decimal places for dollars and cents gives me that. Okay. So that's the answer for that one. Now let's get on to the second one. Okay, so let me try and, okay. So this is a two-parter. How much do you need to deposit today means you have to find your starting amount. So find P. R is going to be 7.2 divided by 100. And 20,000 is what you want to end with. And the amount of time is 15 years. Okay. Now we have two examples. Compounded monthly, so n is equal to 12. And the formula I need is the one for compounded n times a year. And then the other one is compounded continuously. And so the formula I'll need is that one. All right, so let's do the compounded monthly one first. A is 20,000 times P, because we don't know what P is. That's what we're trying to find. 12 and to the power of n times t. Now, we want to find P, so what I need to do here is divide both sides by what P is multiplied by. So when you do that, these cancel, and you're left with P. And so P is going to be equal to this. And I'm going to put this into my calculator all in one go. All in one go. Okay, so let's get our calculator back on the screen. All right, let me just. Okay. So let's clear that. And so I'm going to have 20,000 divided by, in parentheses, 1 plus 0.072 divided by 12, close parentheses, up arrow. Now I have an expression 12 times 15. I'll need to put that in parentheses. This is an older model. And then I'm going to press enter. And that's the amount of money you're going to have to come up with now. And so I'll take it to 2 decimal places, never round until the end. Okay. Now for compounded continuously, I'm going to use this formula and put in what we know. So A is 20,000. We don't know P, that's what we're trying to find. And R is going to be 0.072, and T is going to be 15. All right, so again, to get P by itself, I need to divide both sides by what P is multiplied by. So when I do that, these cancel, and I have my P left, and it's going to be equal to this. So I'm going to put this into my calculator. Let me clear this, and I'm going to have 20,000 divided by, then e to the power of, I'm going to press the second key and the ln key, which is next to the 4, e to the power of 0.072 times 15, and close parentheses. Okay. So if the interest is compounded continuously, the amount of money I'm going to need to come up with is $6,791.91. Okay. All right. And let's look at the last problem. Now, a lot of students will think you don't have enough information to do this problem. Okay. But we do. We do. So let's have a look. My R is going to be 0.035 and compounded continuously. The formula I will need is this. And how long means you have to find T. Now we want to double your money. So you're going to start with P, and you're going to end with, well, if you double your money, it's going to be 2 times P. And so A is the ending amount. So your ending amount is going to be 2 times P. So the ending amount I want is 2 times P, and R is equal to 0.035 and then times T. And now the P's cancel. Okay, so the P is going to be some non-zero amount. And now I need to solve for T. T is in the exponent. So there's a couple ways you can do this. Our textbook suggests, since the base here is e, let's take natural logarithms of both sides. Then I can use the power rule for logarithms here. The power rule says if you have a logarithm and your argument is raised for a power, then this exponent just comes out the front. So if I use the power rule here, then the exponent will come out the front. Now the natural logarithm of e, of course in longhand it's just that, and when your base and argument are the same thing, that just is equal to 1. So this is equal to 1 and it's part of a product. You just don't need it. Now the job was to find t. So I have 0.035 times t, so I'm going to divide both sides by 0.035. So these will cancel, and I'm left with t, and that's our answer. And I just need to put that in years, and I need to put that into my calculator. So let me clear this, and I want ln of 2 divided by 0.035. So about 19.8 years. If we were to round it to the nearest whole number, it would be about 20 years. Usually it's taken to 1 decimal place. Okay, and that completes the video.